Linear motion is motion along a straight line, while projectile motion is when an object moves through the air. Displacement, delta x if horizontal and delta y if vertical, is the change in position from the object's starting point. The total measure of the path traveled during the show would measure the distance traveled. Newton's first law states that objects at rest stay at rest, and objects in motion stay in motion. Newton's third law says that forces are motions. The first type of force is gravitational force, which is when forces interact without touching. Next, the normal force is when forces are perpendicular to each other, when two objects are touching. The force of the football field on the marcher is a normal force. Because the marcher's gravitational force and normal force balance each other out, they do not move up or down. Another force is the friction force, which is present when two forces are parallel to each other. The normal force and friction force are proportional by coefficient of friction mu, depending on the surface the object comes into contact with. The applied force is when another force pushes or pulls on an object, as seen when a pit member pushes their equipment onto the field. Tension force, when a string or or another connecting object is used to pull the object.
The kisses of the sun were sweet.
Work is done whenever a force is applied to move an object through a distance. In order for work to be done, the force has to be in the direction of the displacement. For example, someone picking up their instrument is doing work. Work is measured in joules and is found by multiplying the force by the distance. When there is an angle of elevation, the force must be multiplied by the cosine of the angle first. The rate of work is called power. Power is work over time, or force times velocity. Work done on an object is equal to the kinetic energy the object has. Gravitational potential energy is stored energy due to the object's position relative to a reference level. Potential energy is found by multiplying the mass by gravity by the height. A flag being tossed into the air has both kinetic and potential energy. When a flag is thrown straight up, it has all potential energy at its maximum height. As it descends, gravitational potential energy is transformed into kinetic energy. At all times, the total amount of energy stays the same, neglecting air resistance.
The change in momentum of an individual mass due to an interaction is represented by impulse. The direction of momentum is the same as the direction of velocity. All moving objects have momentum. In marching band, individuals change momentum frequently, usually the result of tempo change. Impulse is force times the change in time, or mass times the change in velocity. This also means that impulse is the change in momentum. There are three types of collisions: elastic, inelastic, and explosions. In marching band, most collisions are elastic, so both momentum and kinetic energy are conserved. Some collisions are explosions, like when the color guard throws a flag into the air. When they catch the flag, an inelastic collision occurs. Kinetic energy is not conserved as some is lost by heat from the impact. In marching band, the band is told to continue marching to their dot even if someone is in their way. On occasion, this results in a member marching into a person.